Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. This is my legitimately purchased KO Pro motor controller that I bought with my money from eBMX. It's been in my possession less than 24 hours. I have taken all the screws out. As you can see, the cover is now loose. There was no nitrogen gas inside. It was not under pressure in any way, shape, or form. The cover is held down pretty securely with a whole bunch of screws. Don't remember exactly how many, but yeah, all around the perimeter of this thing, as you can see, there are screws in there. This cover piece is probably ABS. Looking inside, oftentimes you will find some kind of a molding mark or whatever that tells you what kind of plastic it is, and there's nothing here, which is usually a pretty good sign, especially for Chinese stuff, that this is in fact ABS plastic. I did take a little notch out of the plastic right over here. Yeah, there we go, you can kind of see it. And that was to try to cut the plastic and to feel if it made like crunching feels, you know, against the blade. Because if it did do that, then this was glass reinforced, and it's not. It's just ABS. So yeah, just low temperature ABS plastic is most likely what this is. There are these 5 silicone grommets in the plastic, and they've got silicone around them. Those are to seal against the brass standoffs, of which there are those, you know, to keep water out. By the way, the Battery Plus grommet, they all have silicone around them to seal them to the plastic, but the Bat Plus one, you can see that gap in there. Yeah, so it's mostly sealed, right? That's good enough. All the rest of them, they do have full silicone around them, so that should work pretty well. This connector feature over here is where all of your control signals come in, and there's no gasket on the logic board in any way. Instead, what they did was they put silicone on here and on the circuit board, and just kind of stuck the two of them together. So if you do take your controller apart, this is no longer watertight, not unless you reapply silicone to it. There is a ridge all around the outside. This is a very common technique for sealing things. So when you clamp the lid down to the rest of it, you know, it kind of makes its own watertight seal, because that seal will, or that ridge will press into the silicone seal that's inside the heatsink to make that more resilient. So done with the lid, and here we go. So as you can see, there is this yellow silicone seal all the way around the outside, and that's your water ingress seal right there. That and those silicone grommets on here. Is this controller positively pressured with pure nitrogen from the factory? I would say not likely. Or if it was, it all leaked out before the controller ever got to me 24 hours ago or less. Because it certainly didn't make any hissing sounds or escaping gas sounds when I opened it up. Yeah, I'm gonna just say that's another one of KO many misinformation and lies. No pressurization whatsoever. I have taken all the screws out of here, but I will quickly go through where they belong. So there's an M3 screw here, here, and over here, and then there are M4 screws here, here, and here. 5 of those. And these 5 points are what presses the logic board down to the power stage to get current from the power stage up to here. So there is one of the 5 identical M4 screws that do that. They do not have Loctite on them. In fact, that white stuff is thermal paste. So they can work loose, and all they have is a lock washer on top of them to hold them down. The other 3 screws, the M3s, are these little itty bitty guys with about, I don't know, 5 millimeters of thread or so. Again, not Loctited in. Can certainly work loose on their own and then rattle around inside the controller and create problems. So yeah, that part is, well, not very good. Not that I ever thought KO was very good anyway. I will talk about positive things when I come across them, but so far there hasn't been any of those. The heatsink is pretty beefy, and this is very attractive. So yeah, this is probably adequate for the job. It's a nice hunk of aluminum. It's CNC machined, it looks like, and then it's anodized blue. There's not large, machine marks on everything other than where they want them to be, like on the Moto logo. But everything else is fairly nicely machined. There's not rough edges very much. There's a little bit of a 1 right here. Yeah, that one's nice, but there's a little bit of a rough edge right there, so they did a pretty good job on the machining work. There's not like crossed over machine marks where their CNC machine, screwed it up or whatever. So yeah, the machining work is nicely done. I can't really complain about that, and this is attractive. Yeah, I would not be offended by having that pretty heatsink showing on any EV that I built. But there's other aspects that aren't so pretty. And I have to say that this is a fairly common thing that I find with Chinese products, that the outsides look gorgeous and then the insides are crap. And, well, KO fits the bill for that. Definitely some quality issues inside. So I'm going to now pull up the logic board, which, by the way, right now is only held down by 2 pin headers right there and there. And those are done right. They are long and they're flexible and they can move. And you want that because the power stage and the logic board are going to expand and contract independently of each other. And you want them to be able to move apart from each other. So if all these pins were all locked together somehow so they could not move or flex, that would be bad because that would stress the solder connections on them. And, well, that would cause things to break. And you don't want that to happen. You want them to move. So the board is completely loose. It's just floating on here. All the screws are out. And you can see on camera that I can move it a skosh. That's all the motion you need to make those not stress. So good job on that one, KO. You got at least one detail right. All right, so now I'm going to pull this thing up. And it comes out very easily because all it's held in by is 12 pins. There we go. And there's the logic board loose. All right, first thing I want to point out is KO bragging about import components. That says G-A-J-I-N-G, gauging, I don't know how you say that. I'm probably not even pronouncing it anything close to the Chinese word. But these are Chinese capacitors, not Aishis, not Rubicons, not some really low ESR, big name, high quality component. Chinese electrolytic capacitors. They are 100 volt, 470 UF, and there are 17 of them, but they are just cheap Chinese capacitors. Nothing particularly special about them in any way. Right here is the STM32 processor, and that is the bottom of the barrel of STM32s, so literally like the cheapest one you can buy. And some people have hypothesized that if you do it right, you might be able to get it to run FOC motor control, but it's certainly underpowered enough that you cannot run VESC or the full FOC suite of functionality. So there's a high probability that this STM32 does not have FOC motor control firmware in it at all. Because, well, that's kind of the KOA way, which is to cut corners everywhere that you can. And they have on here. All right, so next thing I want to show you is this. So this right here is the Bluetooth module. Right here, it's got 4 pins soldered into the logic board, and it's got a little blob of silicone right there. And as you can see, I am pressing like about what I would do if I was writing with a pen or a pencil, and I can flex the board. So what's going to happen is, this is going to go on like a Suron or something, right? It's going to see a lot of shock loads. It's going to see lots of vibration. This little Bluetooth module is going to flex like that, and it's going to stress its solder joints, and it's going to break loose from the board and potentially rattle around inside the controller like the screws, which don't have Loctite on them. Yeah, so this is going to come loose, and it's either going to just stop working because it's intermittently connecting up to the main board, or it just falls off altogether. But either way, suddenly you lose communication to your controller. These rings right here, and they have a linear Hall in both of them. That is your current sensing right there for 2 of the 3 phases. Again, this is another way that KO has cut corners. If you look at a lot of your better controllers that are in the same price range as this one, they will have a current sensor for all 3 phases. This isn't always true, but it's a pretty darn common thing. And so 2 of them and not current sensing for the 3rd one, that's just a way to cut costs, cut corners. All right, let's flip this board over. So I want to keep this all in one video. Oh, well, before I do that, one last detail. This is the DC to DC converter. that takes battery voltage and converts it down to something more palatable to logic control electronics. My guess is, I haven't checked, but my guess is that this probably down converts battery voltage down to 12 volts, most likely. Right next to it is a 7805 linear regulator, and over here is a 3.3 volt linear regulator. So this one produces 5 volts, this one produces 3.3 volts. You need 3.3 for the STM32 and for the Bluetooth module. I'm guessing some of these other components need 5 volts, which is why there's this linear 5 volt regulator. For really good designs, you will see 3 DC to DC converters. One for 5 volts, one for 12 volts, and one for 3.3 volts. Not a single one for 12 volts and then use a couple linear regulators, which again is a way to cheapen the controller, cut costs, things like that. Those are shortcuts. They're not the way people that really make controllers do it. I believe that this controller was possibly repaired. This little IC right here, it is clearly hand soldered. It's got flux all around it. It was done after the fact. Everything else here is your typical reflow stuff. The top of the board is otherwise pretty clean, other than that one little part. So I'm guessing that straight from KO, this controller was repaired, and that chip was bad, put in wrong, not soldered down, I don't know. But it's definitely hand soldered. Yeah. Of which the Bluetooth module is also hand soldered. And all the capacitors are hand soldered, including this connector. So let's flip this thing over. Okay, so these two linear hulls right here for sensing current, they are wave soldered. Everything else here is all hand soldered, and you can see flux all over everything. No cleanup was done in any way. This right here is your battery plus bus. Current passes up here through either here or here, and right through this hole right there is where battery plus gets down to the power stage. So anyway, as you can see, no copper reinforcing of any kind. This right here through these 3 positions, that brings battery minus up to this board, and that's basically for ripple filtering for these capacitors. But this is also the main current path for battery plus. Whereas battery minus at least has some really shoddily done copper work on the power stage. And then it also has all of this. So battery minus is pretty good-ish compared to battery plus, which sucks. Also, I didn't notice this when I was posting comments out there on Facebook as Richard Gumfaw, but this right here, you can see this hole, that's where battery plus passes through. This area right here is much thinner than the rest of this. So if this is like 10 millimeters wide, this is like half that, 5 millimeters wide. And on the top of the board, the same thing is there. There's about 5 millimeters worth of width, and this is just standard copper tracing circuitry on a logic board that you'd find from anything. So not beefed up copper, not double gauge or anything like that. Just really thin copper traces on a typical circuit board that would be etched. So right here, this spot, this is smack in the middle of the battery plus bus. This spot right there is going to get really warm, and it's probably going to burn through the board after a while, especially if you're running this controller at near its close to its maximum wattage. That spot is definitely going to get quite hot, and that spot's going to be a failure point. Also, being that there's only 2 standoffs here and nothing in the middle, yeah, it's going to be the hot spot right there, because current's got to pass right through there to get to anywhere else. So that's going to be a cook right there. Also, because there is no copper on here on anything, all these traces are having to carry a lot more current than what they really should be able to handle. And, you know, KO claims 800 amps, and I'm just going to say, yeah, sure, whatever, guys. Not even close, not even remotely possible. Trust me, these traces will not handle 800 amps under any circumstances. Supercool it in liquid nitrogen, and they will probably still not handle 800 amps. Yeah, and under room temperature conditions, definitely not. What's going to happen is those traces are going to get very hot, and they are going to cook these capacitors. So next video will be this board down here. Watch for the next one.